and welcome. We are back. Well, last time we left off with Ninja Gaiden Shadow and we did some really basic stuff. So today we're gonna look into some more actual code and how we deal with some of that. Um, what I skimmed over, basically ignored last time, was when we run the update, we have a few invalid instructions it encounters. So that's all. Like if the Game Boy itself encounters any invalid instruction, it will just crash and stop running. So there has to be some problem why the disassembler encounters this. Um, I already took a quick peek. I know what's going on. So let me explain where this is happening, why it's happening, and how to deal with it. Which is in this case relatively simple. So if we go pick this address and we can just copy it, right click is copy in this terminal. I can just search it here, go to this address, and here it says, well, this is not a valid instruction, so it also stops tracing the instructions. Well, what do we see here before? We see an RST, and the RST instruction, you know what it does because you've read the instruction manual, and if you haven't, you should. Like I told you in the last video, read those things, you need them. You cannot go without. So this calls this specific function. This specific function, if you search for it with a colon at the end, we'll find it. Does a bunch of things. So why is then this happening? If you look at the other locations here, we can go to bank 2. At address 503, it's not even, oh, I'm bank 2. Here. What do we see here? There's a whole bunch of code, and this code looks just wrong. I mean, load B into B is nonsensical. Pretty much, usually if you see anything related to the stack pointer instructions, it's not right. Very little code uses that. But once again, we see here the RST to 0. And if we go to the last one, we'll see that as well. Very likely. Yeah, there is an RST 38. Well, there isn't one here. Oh, there's an RST 0 here as well. So let's look at this RST 0. This RST 0 at address 0. What does it do? Well, the first thing it does, it pops off the current address. So understanding Game Boy assembly, this makes it so you can never return from this instruction. It's not possible to return. Well, it is possible, but it's not very likely you will return from this function because the place you return to, you just put into HL and no longer on the stack. So I could say this function, and there's a special annotation for this, so I can say comment add for an annotation, no return. This function just does not return. And if we then run the update, we no longer have these errors because if we go to this file, to the location we were previously here, it also indicates, oh, these are actually pointers. So we now see that the code, there's no longer code being generated after a call to this RST instruction. But this RST0, it's actually smarter than that. if you look at what it's doing, it takes this address, adds a to it, or adds a to itself, so multiplies a with 2. It's a simple trick. Calls this function, which, if you look at it, does a bunch of things. I know what it does, but yeah. And then gets an address of HL and jumps to HL. So the only thing this function does, RST28, we see add L to A, add, then store A into L. So that's basically, I'm gonna type that here, it's L plus A, and then here if overflowed. So if this result of this add no longer fits into A, increase H. So this effectively does HL plus A. And we can label that. Add HL, HA to HL. And then, because we've labeled this now, we can just run update. We see it here. And we will likely see if we search for this, that this is used a lot. Ah, it's used a decent amount. So that labels already a whole bunch of stuff in the code. Interesting to see. What the hell is this doing? And this is something that happens if you're looking at a disassembly. You get distracted all the time. So you see this function. This adds L to A, and then if it's over, it increases. This adds L to, it's A to L, and then it decreases. So it adds L, but then if it overflows, it subtracts H. So effectively, this does a subtraction of an assigned value in A, but only if it's negative. I hope this isn't used too much because that could be confusing. I'm not going to label it right now because that was not what we're looking at. This is also interesting function. This will be an interesting function that we'll look at quickly next. So this function, but that's what we were looking at. It adds A to HL, and if you see how it's used, we get A from somewhere, do this RST call, and then after this we see a whole bunch of pointers. And what we usually will see, because this is a very common construct, it says this first function that is actually here, because so this is what we call a jump table. Now we could annotate this. We've done this in the previous video, like add jump table, and it will actually work. This is a better way. We can say here that this is a jump table function. I thought it was like this. Let me check. So now we see it no longer builds now, so that is already interesting. It also comes with a new errors where it says, oh, I found instructions that oddly overlap. So somewhere it's processing this in a wrong way. So we can look at the output. Let's first look at the output where we were looking here, because I know it will probably be correct here. If you look at the output, the temporary output, because that's where the problematic part is. But here, well, we see that this is completely turned into function calls. It's automatically turned into a jump table. But Not everything is as good as we hoped, because at address 7063 we have a weird problem here. And I'm not sure why that's happening yet, because I don't see a direct thing from here. I can look at, well, we now have this function. So this is, of course, we should not be looking at the current one. We should be looking at a new one at that specific address. So if we go to that address, it suddenly said, oh, I have an instruction here, but I also generated, for some reason, a call label in the middle of that instruction. And that's basically what this odd instruction overlap says. It's just, I want an instruction here and I want an instruction here, and they weirdly overlap. So if I see where this comes from, I can find this. I'm just going to search in the whole directory, which is Control Shift F. We see here from bank 2. This looks wrong. Like, yeah, okay. This is one of the problems with the jump table function. So here it's been called. There's a bunch of pointers afterwards, but it doesn't know when to stop. So here it didn't know when to stop, because it says here, oh, there's a call. This isn't code yet, and the first pointer that's here is not directly after this table. That sometimes happens. So it sees all of this as function pointers while they are actually not. What they are, I don't know. Probably something. Can I see something quick? Doesn't look. I'm not sure what it is. Now, I think I can just say here that this is a jump table with an amount of 10. I think it's 10. Looks like 10. Oh, of course. Now, and this is something that you will do wrong, I will do wrong. I edited the temporary generated one, but I should be editing the non-temporary generated one. So I just need to go here, go to my input, actual input, and here say jump table amount is 10. It looks like that didn't fix it. Yeah, that's a shame. If I look at my original, what's behind here? I'm looking at this blob, and I'm specifically checking if I see a C9. And the reason for that is, if I go at the with a lot of code, here, C9 is a return instruction, and a C9 at an end of a block of stuff usually indicates, oh, this is code. I don't see the C9 here. Could still be code. The CD is a call instruction. CD. So I'm gonna try and say that this is code, which can use the add code annotation. See what happens. Maybe it's code. I actually managed to build now. It still reports all instruction overlap. So I don't know if it is actually fixed it. I searched for that address again because, oh, as you will notice, if you're doing this large amount of things, it can still generate or change a lot in the structure of the file, so you sometimes just have to jump around. Um, so we now see that this is correct, and my estimate of this being code is correct. I just didn't expect a whole extra jump table behind it. So that's interesting. And then here we see the same problem, and I once again see here CD. So if we put this code annotation here, yeah, this is, I said put code here. Well, that's interesting, because apparently the other jump table got sort of priority. So this is, sometimes you have to experiment a bit with what works for the tooling, what not. Yeah, this is annoying. Oh, I didn't put an add here. That doesn't help. So maybe that completely fixes the problem. No. Oh. Oh, yeah. Now I've run into what I would call a bug. Now it says here that there are two annotations trying to label something. I should fix this in the disassembler, where the jump table should have a higher priority than the call ones. Apparently they don't have right now. Let me quickly create a new window. Let me just dive into that because, well, software emulation. No, wait, this is in Gameboy tooling, BadBoy, the disassembler. Just gonna grab that. I have the simple annotations, and I think this jump table function, yeah, it just always adds this jump table, and I think that's also where we're coming from here. Jump table. Well, here I first have to check if from memory address is empty. That probably won't fix it yet. No, and then I have to check annotations have a priority. The default is 100, and I want to give the jump table itself a slightly lower priority. So there, improvement on everyone's life. So that fixes the whole problem, and I will commit this later and for everyone to enjoy. So you can easier fix these kinds of problems by adding just a jump table after the calls where the automatic one goes wrong. You can also see that I took the size wrong. These are actually 11 sized. Is also here the only the ninth one is that one is numbered, so there's also one more, even though it generated this properly from the instrumentation file. So this looks proper, and this one goes automatically correct because there's code after this. So let me see if the errors are now gone. We also no longer have the old instruction overlap. So it seems the main problem was just around this file. It's also interesting to see a whole bunch of different jump tables all based around the same variable. We don't know what this does yet. We have no clue. That is also not that important right now. we'll figure it out at some point what it all does. Can I see? Yeah, I'm already 20 minutes in, I think. Let's see. We can label this as the execute jump table just to make things pretty. So, well, there was something else I wanted to do, and that's if you look at this function, this write to address 2000, it's usually 2100, but 2000 also works. This is switching ROM banks. And switching ROM banks is important, but what's also important is knowing which is the active ROM bank that is usually stored in memory. We can pretty sure guess that this is the current ROM bank. And like these are small things, but labeling all those small things will make the rest of the code easier to read. This is get a pointer from a this is getting a pointer from a table or word from a table. And this is getting from a pointer. And like labeling these small things, they especially these RC calls that are like really small functions that are used all over the place. Potentially, it makes other code easier to read. You will have a hell of a time labeling everything. That is always the case. It just takes a lot of time. Let's see if we have a lot of current ROM bank. ROM bank. There's a bunch. Here, well, here we can clearly call this switch active bank. Oh, I'm in the temporary one again. I should change that update script, the delete afterwards. I now have the delete in front, and I should do the delete afterwards. So this is switch active bank. And how you name these things, it's all up to you. But we can now see that like, oh, there's a whole bunch of switch active banks. And now we already see something interesting here. Like these, oh, it detected, and that's due to the instrumentation. It knows during this call that bank 2 is active. So it pointed this to bank 2. For this, it doesn't know that bank 2 is active. It's not hit during instrumentation, so it doesn't know. But we can just add, say, oh, bank 2 is active. I thought it was like this, or was it like this? Like this. So now we said during this instruction, bank 2 is active, and it added the label for us. And we can do this for all of these. And that just, no need to manually add labels everywhere. Here, here's bank 5 active. I don't know what it's getting there from, but this is probably a pointer into bank 5, especially if you this get word from table. So we can do a whole bunch of these. And then more code will be code. Because now these, if we search them, are automatically traced. You can see there's a jump table again. Oh, it's automatically adding that jump table. So all of this gets traced out now automatically with this being code, this being code. Here I see. This is interesting. Just random blurb. As I said, you get distracted a lot while doing this. This is an address into video memory. This is the size of the background layer. I would not be surprised if this is just clearing a background or doing some copy. Then this could be a very simple, interesting function to look at. It's not. No, I don't directly see what it does. I can probably figure it out, but it's not interesting enough right now. Interesting enough right now to look at. It's probably writing to VRAM if I look at this. This stat check is very suspicious. But that's not what I also wanted to look at. I also wanted to take another peek at bank tree where we had music data. And the music data, it's interesting, it's fun, it's things here. This smells like some kind of frequency table. I don't know why, it just smells like it. You have this occasionally where stuff just looks like things. I'm just looking here at tables. I'm hoping to find like the table where music data starts. I might not be able to find it. Like this is a suspicious table. But what I find odd is that this has multiple pointers. This is pattern data, as I would call it for music. So this one probably points at what we looked at previously. Oh, this says nothing. We have this one. Also just a whole bunch of bytes. Some repetition in here. So this could all be music data. I didn't look at this before, so I am just lost, so to say. If we search where this pointer comes from. Yeah, this comes from one of these pointers. So these look like music-related data structures, but I have no clue how the data structure works. Most of these have 4 pointers, but some of them have 6. And that might depend on this first byte, if we look at it. I hope to identify some data easier, but I'm not there yet. So this looks all music data, and then all the way down here is where we see some code again. So there's not one interesting thing we can do. We say, oh, I think this is all music data. So we say, we want to put this in a different file. Just, this starts here with these pointers somewhere. I think it's from here. This could be the main music table. It's a bit long with 48 entries. I mean, we only had like 10 tracks or something. But maybe it's music and sound effects. This data before is probably related to the music engine itself. So here we add this. This is a special type of annotation. And we say that this file needs to be in data music. So if we have this pound ink, and at the end of the music data, I added the all the way at the end pound ink end. And very likely, if we run the update, we now See, this file got a whole bunch shorter. That didn't happen exactly as I intended it, because it did put this in a new include file, but it didn't stop at where I wanted it to stop. So I did something wrong. Well, we can fix this manually by just taking all this code afterwards, cutting it out, putting it back here. I did ink and I should have probably done and ink. I can check the code. Ink and. So I have to check what I did wrong here. If I go back, can I still see? Yeah, I did and ink, and I should have done in ink and. So I did it the wrong way around. Stupid me. But like I said, I can just paste this manually back in here, save it. And if I now run the update, it still sees this include. It just keeps it there. So all this music data is still extracted. It keeps being extracted. You can do the include manually, but with these bound ink, it's much easier. So these are still suspicious. I want to see where this is used. How much? Oh, I'm already talking for half an hour. I should quit talking. Let me quickly check where this is used. This is from here. Oh, this is interesting because there's another apparently. Look, there's another table. Gonna annotate this with data format is pointer amount. How many do you think it is? I think it's 40. No, it's less than 40. Look, it went all the way up to here. It should have been 1E is it's about 30 or something. 31. So 31. So this seems to follow a similar format. Oh, that is interesting. So this might be channel 0 and channel 1, or channel 1 and channel 2 of the music data. That it just uses different tables, although I don't think this one was 30. No, this was 48 entries. So where I'm looking here is like, how is this data accessed? Can I see that in a way that makes sense? It's like only getting one pointer from it. It only sees, it adds one. So it gets one pointer from it. It's not the pointers are not grouped. Like it could also be like these four belong together. By looking at the code, I don't think that's true. What it is doing, I'm not entirely sure. With music code, it's usually also the case. This music code, you won't find any calls to the code we identified in Bank 0. The music engines are usually developed separately, so they're pretty much on their own. So you don't see. So the benefit that you had from identifying stuff in other banks isn't as big for the music code. There's also, well, I should stop talking and just post a video. There's probably some info about it already. I'm gonna try this offline and see if I can understand what these F0s and F1 is. It's probably current music track or current sound effect. because this is very suspicious. Like very early in the code. This is probably the entry point for the music engine. Then here, if you want a new music track, start it. If you want a sound effect, play it. That's how this reads. So, and the easiest way to check that is just debugging in an emulator. So we run our emulator, load our ROM, get to the point where it plays sound. Go into the debugger with escape. I press Ctrl G here to go to a specific address and go to FFF0, which is what we had. We put in a 1, for example, and we hear a sound effect. So that seems to be a sound effect. And that also seems to be a sound effect. So there's two different sound effects variables. We can label those. Play SFX1 and play SFX2. So it's not the start music that I hoped for, but it's something. It also identifies that this is clearly somewhere in the start of the music code. Well, we see another thing like this here. If we're doing this, we might as well do it. Make sure we're not. So this is also not starting the music. This might be starting music. And no, it's not starting music. So something in here has to start music, but what it is, we don't know yet. And that's where we're gonna end it right now, I think, because there are various ways to work this out. Maybe I'm just at the wrong spot. Oh, this is a jump table. Look at this. I mean, there's a function pointer here. This has to be a. I mean, it just has to be. Like I said, distracted, totally distracted. Bunch of more calls. Looking here, yeah, that's code. That's clearly code. So, yay. So, this is just me showing how I go through code like this and thinking about it and looking at it. And as I've mentioned before, I think I've mentioned before, it's not easy to do this. It's a lot of work. I find it fun work, but it's definitely not easy. So I'm still I'm annoyed that like one of these things should be starting music. What I could do is go into the sound test, see if I see any memory location that changes if I change songs. And I don't see it here. So if you go back to the music code, there's memory here and there. This. Like, what do we see around here? If you go to So you see a lot of stuff happening here when music is playing. But I don't directly see like where the currently active playing track is. And of course that's always interesting to know, where is the currently active playing track? Because that will be a starting point for a lot of tables and data. And I still don't see anything that I would call current music track, which is a shame. And it might be that it's not visible here, like that it's started from from a variable, and that it's always erased to 0 afterwards, and then we don't see it. But I do see, and that's something I once again get distracted. C500. If I look at the sprite OEM stuff, I think this suspiciously looks like sprite data. I think these bars are drawn using sprites. See, they are drawn using sprites. So I think this is the Shadow OEM. And C600 is probably Shadow OEM. This needs to be aligned to 100 adders, so it's usually easy to identify. And we'll probably get some reference from it somewhere. And from that you can usually trace where like draw sprites and stuff is. However, this might be that it's only used during the sound test, seeing how few references it has. So I'm not convinced that this is a shadow. I'm gonna leave a note for myself here. It's only during sound test. Because let's see what happens. I also labeled the wrong one, right? I need 500. That's probably why I didn't see. Oh, that's even less. Oh, but this is very suspicious. This is the size of Shadow OEM. So yeah. Here, oh, we see sprites, and those correspond directly to here, these numbers. So yeah, this is just a Shadow OEM. I can label that. I don't know why there's only one reference. There's probably some trickery to it. This is a clear mem. Oh no, it's a clear memory. This memory to clear, and BC is size to clear. Like this is just, you can add comments like this. They get preserved through the update process, as you can see. And we have another call here. This is called from somewhere. And this is probably just a memory set. Mem set. And that follows basically the stream structure, except that D is value to set. And once again, this just labels automatically stuff. It makes it easier to read some code. Clear shadow. OEM. So, not as deep as a dive into the music code as I would have hoped for now, but I hope you learned something from this. As I said before, don't like, don't subscribe, because fuck that.